My name is Yael. I'm from the Computer Science Department at Bar-Ilan University. And today I'm going to present to you a very big project that I've started at Tel Aviv University. That's called crowd mining. As I said, it's a very big project. So in the time frame that I have, I will try to give you a glimpse into this very interesting world of crowdsourcing and what we have done with it in our context. Okay, so one thing that we'll focus on here is the different types of data that one has to manage when dealing with crowd contributing data. Okay, so let me just start to ground everything that I'm going to tell you today with a very simple, intuitive example. Assume you're planning a vacation. So in this example, Anne is planning a vacation in New York City, but it could be any one of you, a very common situation. She's going to New York City with her kids, so she's looking for specific activities she can do in a nice location, a restaurant nearby, relevant tips, and so on. Okay, so it's a very standard situation. What we would like to be able to do is to answer these sort of questions. Okay, sounds very reasonable as a target. The answers that we might expect would look something like the question. So you can play baseball in Central Park and eat at this restaurant. Also, you can apply for a ball field permit, or you can go visit the Bronx Zoo and eat at a different restaurant. Okay, so the structure of the answers should be something like the question that Anne has asked. Now, this seems very simple, but actually it's quite a complex problem because the question involves many components. In particular, this question involves components that are very easy to answer. For instance, names of activities in New York City, names of attractions in New York City is something that it's very easy for me to find out somewhere. Okay, I can find some database of restaurants in New York City, and I can just retrieve this data. What's harder for me to find is the parts in pink in this question, which are more related to individual opinions, recommendations that people might give to Anne. For instance, the recommendation to go to a specific restaurant after doing a specific activity. For instance, not every restaurant is suitable after a sweaty activity outdoors and so on. So this is something that's more subtle, more related to individual opinions and habits of people. Okay, so keep in mind these two types of data. This is exactly what we're going to try to solve when we're developing a solution to answering these sort of questions. Okay, this is of course just a question for the travel domain, but it can occur in many different situations. Okay. So what would you do? I mean, it's a very common problem that you need to address in your daily lives, planning some trip or so on. So what would you do in this case? Probably you will start by opening your web browser and start searching for different activities in New York City and so on. The problem is with web search is that the only thing you can find is web pages that are already there. So this means you would probably need to do something more than web search, but rather than something like web research. Okay, you would have to go over many pages of possibly relevant data, try to understand what's going on, what restaurants can be combined with different activities and so on. So unless somebody has already wrote a page that's specific to your question, even though this is nothing that's very unusual, right, visiting New York City, you're still going to encounter many pages that only contain parts of your answer. So you still have a lot of work to do. Another alternative for people who are more lazy, perhaps, or more patient, on the other hand, is to go and ask in some form this question, this specific question that you want to ask, and hope that some people who are expert in this in this specific question would give you some relevant answers. So you can enter some travel form and ask, okay, what should I do with my kids in New York City? Now, this is better in the sense that you would get, after a longer period of time, but you would get answers that are specifically relevant to your question. But the problem is that the answers are highly dependent on who is viewing your question, on the specific perspective of the person who saw this question and decided to answer it. And it's really harder to tell whether we can trust the answer, whether we're not missing something, whether there's no redundancy in the answers, okay? So still the user has to do some work. What we would like to do is we would like to find answers that we can guarantee that in some way they can be trusted and that they are in some way comprehensive for the user, okay? So this is the approach that we want to, that I want to present today of crowd mining. So just a background, I guess many of you or most of you have heard the term crowdsourcing. It's being increasingly used in many different contexts nowadays as an alternative means of performing tasks where we decide to use the power of web users instead of trying to develop automatic algorithms or use experts to perform the tasks, okay? So these are very, very well-known examples of crowdsourcing. Wikipedia is perhaps the most well-known one. So in platforms like Wikipedia and TripAdvisor, users log in and they feel like a part of a community, so they want to share their knowledge. In some other cases, users are just playing a game, and while they're playing this game, they are contributing data. So this is a different approach for engaging users to contribute data, like in the Galaxy Zoo and Foldit games, where users are contributing, playing some games, and contributing data related to galaxies or related to foldings of proteins. Okay, and there are, of course, ways of actively asking users to perform certain tasks, like in platforms like Amazon Mechanical Turk, or I saw that Crowdflower are sponsors of this event also. Okay, so there are different ways of engaging users to perform tasks. Specifically here, we want to engage the users to contribute relevant data for the problem that we have in mind. Okay, so what are we going to do here that's going to be smarter than just a forum? Okay, how can we do better here? How can we make a better use of the knowledge of people? As I said, we want answers that are comprehensive, that can be trusted, and in some sense, we also want to save some effort for the users. Okay, writing an answer to someone's question could be a very laborious task sometimes. So we want to make sure that the users don't have too much effort. Okay, so the basic ideas that we're going to implement in this framework that I'm going to present is, first, we want the system to actively generate questions to the crowd, as opposed to hoping that somebody would contribute some data that's relevant. We want the system to actively, automatically generate questions that are going to be as specific as possible to really ensure that we get the piece of data that we need to answer the question. For that, we're also going to decompose the initial question that we get from the user into smaller parts that are easier to answer and are easier to manage and to control. Then, whenever we have data that's already recorded, we're going to prefer to use it. The crowd is a very expensive resource in terms of latency. The time takes us to get an answer from the crowd. Sometimes we pay users for their answers, and they have limited attention span. So in general, we want to reuse existing data as much as possible. Okay, so crowd mining is all about finding answers, okay, which I refer to also as data patterns that fit the question, the original question of the user, that are relevant, that are comprehensive, that are significant, and that comprised of data that's both general, like the example I gave you before, like names of restaurants, but also individual data, which refers to opinions, recommendations, habits of people from the crowd, which is the main data for which we're going to engage people to give us information. Okay? I'll give you an overview of the process, what it generally looks like, and then I'll show you the general framework, and we're going to zoom in into different components and see how it works behind the scenes, okay? So generally, we have some questions. Say Anne logged into our system, posted her question, and we also have some database of existing knowledge that we're going to use. In this example, this is a knowledge base in RDF form. The model is not so important in this case. Okay, but it contains some data of restaurants, of activities in New York City, things that are very likely to be found in a knowledge base. What we're going to do is we're going to incrementally explore different patterns relevant to the question. For instance, playing ball games in Central Park could be one of these patterns. Okay, so when we generate this pattern, we don't know if it's going to be relevant to the user or to anyone. Next, what we're going to do is we're going to generate questions related to these patterns to the crowd members. Some of these questions could be to determine the significance of the pattern. For instance, asking people, so do you do this and that? How often do you do this and that? And some questions will make us discover potentially more relevant patterns, like what other games do you play in Central Park? Okay? And what else do you do? What relevant tips can you give for this specific pattern? Then we're going to evaluate, based on the answers of many different people, the relevance of some answers. We're going to aggregate them. And eventually, we're going to summarize all the findings into a concise answer provided to the user. Okay, so this is an overview of our framework. As I said, we're going to zoom in into different components of it. But generally, as you can see here, the user who is posting the initial question, and in our example, starts here, posts some question, and then the system performs different analysis on the components of the question. In particular, some of them are going to be sent to the crowd in the form of specific questions. So the challenges that we have here in a very high level. We want to be able to compile an initial question into some declarative formal language so that we will be able to decompose it and optimize the evaluation of this question. We need to decide which questions we're going to pose to the users by our system, okay, to identify the pieces of data most relevant to be asked about, and we need to be able to analyze the answers. And also take care of other aspects of the problem, for instance, personalization, how we're going to find answers from users that are more relevant to the user who asked the question. Maybe Anne only wants to get answers from residents of New York City, or maybe just from people who have kids. Okay, so we're going to talk briefly about the different components of this system today. You can see the small map here on the top. Okay, so we're starting with the knowledge. We're assuming that we're starting from some existing knowledge base. This could be a publicly open knowledge base, but it could also be a domain-dedicated knowledge base. And we also have some knowledge inferred in previous rounds of the system. Okay, so this could look something like that. This is a very simplified part of the knowledge base containing data about places in New York City, activities, restaurants, and this can be enriched by names of further restaurants or by observation that people visit very frequently in specific restaurants. Now we take this knowledge, and based on it, we want to be able to evaluate the question of the user. First, we want to compile the question of the user into some declarative language. As I said, we want to be able to find an optimal or a near optimal plan of how to compute the answer to this question. So we're going to translate it into declarative language. You can see here a very simplified form of the language that we use. And what you mostly need to know is that it is composed of two distinct parts. The first part is related to things that we can find in the knowledge base. And the second part is related to questions that we're planning to ask people from the crowd. Okay, so the knowledge base is mostly related to restaurants, activities, geographical locations, for instance, which is something that we can obtain from the knowledge base. But what we want to ask the crowd is, for instance, what combinations of activities and restaurants do they do? Because, as I said, not all of them are compatible. What tips do they recommend while you're doing a specific activity? Okay, so this is the most important part, this distinction between the two parts, because we're going to execute them in very different ways. A user might not be able to just come up with this query in a formal language. So in our system, the user initially could form the question in a graphic UI, which essentially limited the expressiveness of the query. But in a more recent work, we added a natural language interface. So this is much more expressive. The user can enter a question in natural language, and this gets translated into the formal query. I won't get much into the details here. Let me just say that the important thing here is to identify the different components of the user question related to the different parts of the query. So here, for instance, popular combinations would be something that I want to ask recommendations for, and this is something I need to identify, as opposed to restaurants nearby, which is something I might be able to discover in my specific knowledge base. Our query engine, what it does, it decomposes the query into smaller parts. So for this sample, just look at the part asking for an attraction and activity. Okay, so we want to find evaluations for X and Y for an attraction and activity respectively, and we want to find a good combination of them, which is something that we're going to ask the crowd. So we're going to instantiate X and Y from the knowledge base, and based on that, we can generate a formal form of the task to be posted to the crowd. Okay, so this can be associated with a budget and so on. The advantage of this approach is that we're not going to ask any sort of question, but we are able to find questions that are more relevant. For instance, we could be able to start with the general question of whether people go to Central Park, and then we can ask more specific questions about what activities do they do there, for instance. Okay, now, once we've determined the tasks that we want to evaluate, we're also going to select the users that we want to perform these tasks. So this is a more recent work that we did. Just in a glimpse, because I don't have much time, I'll just say that the important thing here in user selection for these tasks is that it really depends on the task. So we cannot train a model in advance to be able to select the most relevant users. The tasks are pretty complex. And it also it's highly dependent on preferences of users, of the clients who ask the original questions. So our system enables a selection of users, of crowd members, that's specific to the task, that's declarative, so it can be customized. And we essentially take all the parameters that are usually considered when selecting users, like expertise, people who are familiar with New York City, like similarity to the user asking the question, as I said, people who have kids, for instance. And we provide a generic formulation for selecting these users. Okay, so this could be customized to any specific setting. We don't need to train a model for each case. Still, we are able to find the most relevant users for every task. This is the only graph I'm going to show in this presentation, although I have many graphs, but the main idea is that we want to find some intersection between the user profiles that we already have, that consist of both data that the user gave us and answers that the users gave in previous tasks. And we're going to intersect it with the task using some dedicated similarity metric in order to decide how relevant the user is to the task or to the profile of an, and so on. So this is a generic means of determining both expertise, relevance, similarity, all in one formulation. We have a p-time algorithm, very efficient for computing it. And as you can see, very surprisingly, it also surprised us, we are able to select users better than dedicated. So we've tried it in different scenarios, but we outperform different machine learning algorithms and link prediction algorithms depending on the setting, which was very surprising for us because our formulation is generic, okay? It's not dedicated to any specific context, and it's also declarative in the sense that the user can say exactly how the people to answer the questions are selected. Okay, so this was a very positive result for us. Next, what we're going to do, having selected the tasks, selecting the users, we're now going to post the tasks to the users. So it might look something like that, asking a question, how often do you go to play baseball in Central Park? We're going to collect the answers from different users. And this is done through a dedicated UI. In this case, this is a community-based UI where people were asked to answer questions and were awarded stars. In this case, we didn't give them any money. And still, we could get many answers. The users were competing among themselves. They get the question in this form, so you can see it's a bit graphical, just to tell us on their habits, on their recommendations. Once we get the answers from different users, what we need to do is to aggregate the answers to discover how likely is this specific pattern to be significant. So for instance, if I'm asking about ball games in Central Park, I would like to know whether this is something I can already recommend on. Do I need to ask more questions, or can I decide that this is not relevant to Anne's question at all? Okay, as you can probably imagine, this will also affect other tasks, because if nobody plays ball games in Central Park, I don't have to recommend specific types of ball games, for instance. Okay, so we want to aggregate the answers, estimate the significance of the pattern, and we also want to decide how likely is more question to give us benefit, and this is exactly what we do in our model. We estimate the probability of error given the current data that we have, and then we decide whether more questions can help us there. So this was a very brief overview of what we do here. Let me just summarize what I talked about today. I've presented the crowd mining framework that we have that leverages crowdsourcing platforms, but in a very specific way, where we want to find complex answers to complex questions. What we do is we actively generate the questions to the crowd by decomposing the initial question. We have a generic architecture and implementation for different components that I just very briefly showed you today. And we make use of the semantics of the data in order to be able to ask the very best questions, the most relevant questions, and come up with answers that are aggregated from many users. So each recommendation that we give was supported by several users, so we're pretty sure that it's relevant. But also each user had to mostly done very simple tasks, just as marking in the web UI, okay, this is relevant, this is irrelevant. And this is something that our system allows. Okay, we're still working on different extensions of the system. For instance, diversification of knowledge sources, exploration of knowledge rather than just providing a fixed answer. So if you're interested in this field, you're welcome to contact me. I'll be happy to tell you more about it. Okay, some related work. Thank you.